we have been trying to determine the sensitivity, the climate sensitivity of CO2 for decades. Are we close to find a current answer?
That's a very sore point among climate modelers, as you probably know, is that through the years, that range of the climate sensitivity, whether if you double CO2, will it warm up 1.5 degrees or 4.5? That's kind of in the range. And the latest models show an even wider range, going up to 5.6. So the answer from the scientific community is we don't know what's going on, because every time we have a new model, we get a completely different result. And right now they vary over a factor of 3, which is a huge error range for any kind of science, a factor of 3. Our calculations with real data, with empirical data, where we know how much extra forcing was put on the climate system and then what the temperature response is over the past several decades, we get a number right at the bottom of that range, about 1.5, 1.6, 1.7, which has very little impact in terms of climate events on the planet.
So if CO2 is not the dominant factor in the climate system, what is? Do we know?
Well, if you're talking about dominant factors on many time scales, on say a year or two time scales, we know what that is. That would be volcanic eruptions or El Nino, La Nina, the ocean circulations. As you go into century scale, now you have to talk about how the oceans change in their circulation. And is that going on right now that's fooling us, that's just fooling us about what carbon dioxide might be? And that is the real crux, is how can you know the impact of the extra carbon dioxide when Mother Nature is also playing big roles in causing changes? It's very difficult to extract one from the other.
I've seen a research recently with some civil physicists who saw a link between the sun's solar cycle and the El Nino. I don't know if you see that paper. Is that something you also go into your research, or are you just focusing on the atmosphere?
Well, I've looked just at the last 40 years with our satellite data, and for the stratosphere way up high in the atmosphere, we see a very strong link between the solar variations and the temperature up there. But down in the troposphere, it's much harder to find just on a 40-year time scale. But on the longer time scales, I have seen some results that show that the variation in the strength of the sunspot cycle, or really the solar irradiated flux that comes into the Earth, does have a relationship with the land surface temperature. And so that's another one of those Mother Nature factors, those natural factors that confuses us when we try to figure out what the carbon dioxide signal is.
As many factors who play all the time, and they can make each other stronger, and they can make each other weaker. So.
And we cannot forget the factor of internal variability. This is not dealing with the sun or volcanoes or anything, just within the climate system itself. It has the capability to organize itself and create hot periods and cold periods. If you look back through the history of time, you will see that just naturally the climate can have these large variations.
Is that due to the ocean atmosphere connection, or is it an atmosphere layer who plays, or where does it come from?
These kind of variations are primarily, I believe, driven by the ocean circulation and the atmosphere response. But I have to say the atmosphere also has impact on the ocean, so it is a two-way street. You know, why do so many indicators show that the Earth was warmer 1,000 years ago? Especially in many regions, it was just warmer 1,000 years ago than today. The sun really hasn't changed that much in that time period. So what other kind of natural variations would have occurred to create that warm period?